Hi and welcome everyone to part 7 of the supplementary coding along video series for the Build a Large Language Model from Scratch book. My name is Sebastian Raschka. I'm the author of this book, and in this video I want to teach you how to teach LLMs to follow instructions. It's essentially one of my favorite topics. You, of course, probably are familiar with ChatGPT, where we can ask ChatGPT simple questions like translate maybe hello world to German and other simple things, or even complicated things, and the LLM will assist us with that. And so we are building in this chapter a small personal assistant that can do similar tasks, and in my opinion that's one of the most fun things one can do with LLMs. So in the grand scheme of things, where we are here in the final section of this book. So previously we coded the LLM architecture, set everything up to pre-train the model, and then we loaded the pre-trained weights from OpenAI. And using those weights in the previous section, we fine-tuned the model as a classifier, which was fun. And so the model was able to say whether a text message was spam or not, but it was also pretty limited. It could only say spam or not spam. So in this chapter, we will be making the model a bit more general, that it can that the model can respond with free-form text, and it can also process multiple types of queries. So it's more able to understand what we want from the LLM, and it is more flexible and can do more things. Of course, the model we are going to develop here won't be as powerful as something like ChatGPT, because that would cost us millions of dollars, and we want to keep it a bit simpler for educational purposes so that you don't have to spend millions of dollars. But the concepts are similar. So here we are just doing it for a smaller model with a smaller data set and so forth. And yeah, I think it's a lot of fun, and it also helps us understand essentially how these technologies or how these techniques work that we use to develop these technologies. So for that, like I start every notebook, I will first show you the software libraries, the Python libraries I'm using. So here there are no big surprises. Everything here is the same that we used for chapter 6. And by the way, just going back here, this chapter is independent of chapter 6. So you can see here in stage 2, we had the pre-trained model, and then we loaded the pre-trained weights. And then there's this fork here where we either fine-tune the model as a classifier or as a personal assistant, but you can see there is no arrow going from here to here. So it's totally disconnected to chapter 6. It's just that some of the ideas in chapter 6, like the fine-tuning, that of course also applies to personal assistants, where we start with a pre-trained model. But similar to chapter 6, we will start with a pre-trained model. But yeah, if you have watched chapter 6, these libraries are the same, because we still need briefly TensorFlow for loading the OpenAI weights, but then all the other libraries here, matplotlib for visualizing the loss function, TickToken for tokenizing our inputs, Torch as our main deep learning library, this is still the same. So everything else should be similar to what we have used before. And then let me show you also the different steps we will be going through. So it is going to be, I would say, a relatively long chapter, but I think also many of these concepts are quite familiar. So in chapter 6, for example, we spent a lot of time setting up the data set. Again, we have to set up a data set. It will be a different data set, but many of the ideas also still apply. So even though it might look a bit like it's a long chapter, a lot of this will be quite familiar because we already spent so much time working on these things. Yeah, after preparing the data set, we will be loading the open weights from OpenAI, similar to what we have done in chapter 6. And then the fun part will be instruction fine-tuning the LLM. And then I will also show you how we evaluate the LLM. Because yeah, if we have free-form answers, like this, it will be a bit trickier to evaluate how good the answer is, because in previous chapters we could just compute in chapter 6 the accuracy. We can see 50 out of 100 predictions are correct, so we can say it's 100%, 50% accuracy. Now it's hard to say because it's more free form. It's hard to say what is correct or not, especially if we have trickier answers where there can be multiple correct solutions. So if I say, what is the synonym for happy, there might be multiple synonyms that has no one correct answer, for example. So it will be a bit more challenging to evaluate the LLM, but we will get to that in due time. First, we have to, of course, fine-tune the LLM. And for fine-tuning the LLM, we do need to set up the dataset. So should have added the section title. So the section title here is preparing the dataset for supervised instruction fine-tuning. So the dataset, I will just put it here because the code is not super interesting. So what we are doing here is we are downloading a dataset that I prepared. So I just call it instruction data JSON. And this is on GitHub, in my GitHub repository here. And here I'm essentially just downloading the file. So the file has 1,100 training examples. So it's relatively small, and this is mainly to keep the time that it takes to train the model relatively short. So I think it takes about, again, 5-10 minutes to train the model. Of course, the more the merrier. So typically LLMs, they are instruction fine-tuned with, I would say nowadays, at least 100,000 training examples. But again, this would be more expensive. So for educational purposes, this is a simpler data set I developed here. And we can take a look at some of the entries to get a sense of how it looks like. So JSON is essentially, it's a text file, but it looks like a Python dictionary. And so you can see each entry. So here I'm just taking the entry at position 50. Is a Python dictionary now. And so it has 3 input fields. It has an instruction field where it's, including the instruction, identify the correct spelling of the following word, for example. And then the input field contains the word that corresponds to this instruction. And the output field contains the answer that we want the LLM to generate. Maybe let's take a look at another one here. So here we have one where we have an instruction, but we don't have an input. So the input is empty. So we could also have a format like that. So for example, I could also technically, if you look at the, here we go. So if I look at this format, and I can also convert it into a format where we don't have an input field. For example, I can maybe restructure it like this, and then it will be also a similar format. So it's not super strict. The reason also why I structured it like that is, and like here, it's the classic format. It's called the alpaca format. So, but you don't have to strictly use that format. I think in the appendix section here in the references and further reading materials, I also suggested some other data sets that are available on the internet, and not all the data sets follow this instruction. Honestly, it doesn't really matter. We can make it whatever we want. We can define our own format and our own style, because we will be also defining our conversion style, everything, so in a few moments. So I would say, don't get too stuck on how this is formatted. This is just one way of formatting the input. Let me maybe go back here and show you a figure. So the input is in JSON format, for example, like I mentioned. And then next, what we are going to do is, because we are not feeding the LLM in data in this format, we are feeding the LLM plain text. So we are going to convert this dictionary structure into human-like text, how a human would provide the instruction. So here, this is one way we can apply a so-called prompt style template. So a prompt style template takes this dictionary and converts it into text. And this is the alpaca prompt style template. Alpaca is one of the first, I would say, publicly available resources that did something like that. So it's kind of like a classic, and here I'm using the classic just because, it's the foundation or the original that most people are familiar with, or it's just like, one of them, one popular one. Of course, there are also other styles, but focusing for the alpaca on the alpaca prompt style for now, it works as follows. That we take an entry here, and then we prepend something. So we prepend this boilerplate that says, below is an instruction that describes a task. Write a response that appropriately completes the request. And then we have an instruction field. So it takes this line here, adds some markdown syntax sugar to it. And then we have the input field and the response field. And again, this is just one way of preparing this. There are many other styles. Actually, each LLM nowadays has its own style. If you think about other LLMs like Meta AI's Llama models, Google's Gemma models, or Microsoft's Phi models. For instance, here I actually have an example of the Microsoft Phi 3 style. So here they used something simpler, where instead of having the boilerplate, they don't do any boilerplate. They just have the instruction directly here. There's also no input field. They merge the instruction and the input into one, and that is like users designating the user input, and then this is what the LLM should respond under an assistant field. So that is another way of formatting the input. Actually, I like this because it's shorter, and shorter is cheaper. So because if you think back of how the model generates text, the model is generating one token at a time. And so if you have twice as many tokens, it will be requiring twice as many iterations. So it will be more expensive to run the LLM. And so the shorter, usually the better. But yeah, we are using the classic here because I think it's good for educational purposes to, use something that is quite popular, and this could be a reader exercise. In fact, if you read the book, there are a lot of exercises throughout the chapters, and I will leave you to this exercise to, try out different style templates and see how it affects the performance. But yeah, so this is what we are going to code now. So we are going to convert this into what we have just looked at, this prompt style. So let me show you the function. This is a very simple function, format input, where we have the instruction text, and we have here the boilerplate that I just showed you. And then here we insert the instruction, this part, the content here. And then if we have an input field, we will provide the input. So we will create this if we have an input, and otherwise we will just leave it empty. And so this will be giving us the instruction plus the text. So let me call this on our example buff, the one we have here. Of course, I need parentheses. I don't know what I was thinking. Okay, so here, this is how the LLM will see the input. You can see we have these new line characters. So this is how the LLM would see it. For us humans, of course, it's a bit easier to read if we actually render these new line characters. So let me add a print here. So this is how the LLM would see it. And then we also need a response. So for example, we can write a desired response. So let's also maybe check out the other one here. So this would be that one. So we can see here there is no input field because the input is empty. So that worked. And then, yeah, we can also add the desired response. So the desired response is only provided, of course, during training, during inference. When we use the LLM, there won't be a response. So because the LLM is supposed to generate it. So here, but for the preparing of the training data, we will include the response. And by the way, I wanted to mention one more thing, maybe if that's confusing, because when we use this here, the ChatGPT interface, we didn't provide anything like that. So we didn't, we didn't input it like this, right? So we could have done this, but we don't write it like this, right? Because it would be really tedious if we as a human write the style out every time. And so in fact, LLM providers, they do this already in a sense internally, so behind the curtain. So it's similar to what we're doing here when we only provide an input and then we have a function that takes care of the formatting. Similarly, other services, they also do this behind the scenes. So we as a user, when we will get to that later, when we write the instruction, there will be something that will be prepared in the background, but we don't want to bother users typing this. So this is why you don't see it, why something like this works and why we don't need this whole thing here. But anyways, getting back to the topic, so how we would prepare the training data. So this would be the data for pre-training the model. And then lastly, in this section, let me also prepare the training, test, and validation splits. So we will be using 85% of the data. So we have 1,100 entries. We'll use 85% for training, 10% for testing, and then the remaining 5% for validation. And so let's just briefly look at how large these sets are. So we have 935 training data points, 55 validation data points, and 110 test data points. And so in the next section, this will be a bit, I would say, it will be very important. In the next section, I will show you how we prepare this in terms of the batches. We will define the dataset class, and then also later we will talk about preparing the data loaders that we can then use during the fine-tuning.
Get this book at manning.com.